What are forces? We can talk about two different categories of forces. There's the contact category, which requires two objects touching. And this includes me pulling on this, me pushing on this. The fact that these two objects are touching is causing contact force. It could be friction. Friction requires two objects touching in order for there to be friction. If two objects aren't touching, there's going to be no friction. It could be tension, such as this eraser being held by a string. This is causing tension force. It could be me pulling this eraser along. That is also tension. So these are examples of contact forces, two objects that are touching and acting upon each other. The other type is going to be non-contact, such as gravity. And then the other one is going to be that of magnets. So pushing against each other, repelling here, or in the case other direction of magnets, which is probably a little bit more fun, and that is that attracting. And these do not have to be in touch for the magnets to work. And yes, I suppose you can consider Jedi Force a non-contact force as well, if you would like. So that's what forces are. Either things interacting because they're touching, or things interacting and not touching. With forces, we need to keep in mind that forces are vectors. They have both a magnitude and a direction. So we will represent forces with arrows. The bigger the arrow, the bigger the force. The smaller the arrow, the smaller the force. And this gives us a really nice idea using arrows to tell us the relative size and the direction of a force. The units for force is newtons, named after Sir Isaac Newton himself and abbreviated with a capital N. And speaking of Sir Isaac Newton, that gets into the first law, which is the law of inertia. And that's commonly recited as an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. Okay, so you just saw a variation of a classic demonstration in the law of inertia. Now, before we go any further, we need to define what inertia is. And inertia is an object's resistance to a change in velocity or change in motion. Now, do remember that velocity is another vector, has a magnitude and direction, and we can keep the magnitude and change the direction and get a new velocity. So with the demonstration that I just showed you, is that inertia wants to keep the coins as a nice tall tower. And it's going to resist any change, but resistance is futile when you apply enough force and quick force with a butter knife. And that external force on the bottom coin causes the bottom coin or bottom two coins to shoot out. Inertia is what keeps the rest of the coins as a tall tower, and does drop down due to the external force of gravity. An everyday application of the law of inertia is when you are in a vehicle and suddenly the brakes are tapped. The brakes are a force applied only to the car. Inertia, your inertia, is going to keep your body's velocity going until acted upon by an external force, such as hopefully your seatbelt, or the chairs in front of you, or an airbag, or the windshield. And if the windshield doesn't stop you, then unfortunately the external force that's going to stop you is going to be something outside of the vehicle. So your body isn't going to stop when a car's brakes are tapped, because until the moment something else acts on your body, your inertia is going to keep you moving at that velocity. Hopefully this helps you understand the law of inertia, and I'll be covering Newton's second law and Newton's third law in another video.